In this session, I am discussing about sewage treatment and sludge disposal. Sewage is a byproduct which comes out from our homes. It is a liquid waste and it has to be treated properly before discharging into the our river streams and all. Now, the key learning objectives of this session are to understand the sewage generation and typical characteristics, to understand the conventional sewage treatment systems, to know about sewage sludge generation and disposal, to get information on various land treatment methods, and also to know about working of on-site sewage treatment system. So, popularly we are using this septic tanks at our houses as decentralized systems also. Now, what is sewage? It is the wastewater produced as a result of water use for various daily activities, which includes cooking, bathing, drinking, flushing, etc. Sewage is considered a mixture of grey as well as black water. So, grey water generally it comes out from the bathrooms, kitchen sinks and laundry, and some places grey water it is actually coming from bathroom and laundry only, while the black water it is basically which is coming out from the toilets. Disposal of domestic sewage from cities and towns is the biggest source of pollution in water bodies in India, and it has to be treated properly. The wastewater which is produced is contaminated by various organic as well as inorganic impurities, and due to scarcity of fresh water, sewage actually it is also emphasized that sewage should be recycled after appropriate treatment. But in this session I would be more focusing only on the conventional methods for sewage treatment. This slide shows actually the sewage generation and treatment in class 1 cities and class 2 towns in India, and it is taken from CPCB, Central Pollution Control Board. So, here this is class 1 cities having more than 10 lakhs population. So, this is total 39 number of cities are there, and you can see that how much sewage is generated. This is in million liters per day, it is 13,500 million liters per day. Installed capacity is only 4472 MLD in 29 cities. So, there is a gap between the cities having STPs and all, and sewage generations in the cities having no STP is also given here. So, there is also what is the total capacity gap which is actually shown in the second last column. So, that is 9,000 for city class 1, and there is a planned treatment capacity is still it is much lower than the total capacity gap 1549. So, in this manner we can see that is actually sewage generation from class 1 cities and class 2 towns, it is approximately 30,000 MLD, and installed capacity is only 6190 MLD. So, there is a huge capacity gap, and now in fact in the metro cities also government is planning to have more STPs, so that the wastewater sewage could be treated properly, and also there would be efforts to recycle the drinking water. So, this slide shows the typical characteristics of sewage or domestic wastewater. The sewage can be categorized as strong, medium and weak depending upon the values of various parameters. Some major parameters are listed here. So, this is total solids, biochemical oxygen demand, chemical oxygen demand, total organic carbon, nitrogen, phosphorus, alkalinity and chloride. We can see here this biochemical oxygen demand to COD ratio is approximately 0.4, and the wastewater is considered biodegradable in nature. Biochemical oxygen demand refers to the oxygen required for the microbes to degrade or oxidize the biodegradable organics present in wastewater, whereas COD is the chemical oxygen demand, and it refers to oxygen required to completely oxidize biodegradable as well as non-biodegradable organics present in the wastewater. So basically BOD5, it is actually for the biodegradable organics. It tells us about biodegradable organics. These are the lumped parameters which are used for measuring organic pollutants present in the wastewater. Now it is assumed that around 75 to 80% of the total water supplied, it appears as wastewater or sewage. So this is a thumb rule. So if we know the water supply in a city, then we can predict the amount of wastewater which is going to be generated, and then also we have to actually also predict. Some forecasting methods are there, population forecasting methods, based on which we can predict how much water would be supplied to that particular place, and then how much wastewater has to be is expected to be generated. And depending upon the amount of wastewater and projections, we can design the sewage treatment plant. Now there are various stages in a typical sewage treatment plant, which include preliminary treatment. So the units of the preliminary treatments are screening. So the large particles are actually removed by screens. Screens may be coarse screens, medium size screens, or fine screens depending upon the pore opening. Second one is the grit chamber. So grit chamber are used particularly for the removal of inorganic impurities present in the wastewater, and there are some aerated grit chambers are also there, so where air is also supplied so that the lighter material is kept in the suspension, and the you can also actually remove the oil and grease also. So this is like skimming tanks are used for that purpose. Primary treatment, it is actually a sedimentation tank, or it is called primary clarifier. So where the suspended impurities are removed. So this is the second this treatment stage. Now the secondary treatment, that is also called the biological treatment. In this stage, after removing the suspended organic and inorganic impurities in the first two stages, the wastewater is subjected to biological process. In the biological process, microbes act on the dissolved organics and then they convert into stabilized products, or they oxidize them. The last one is the finer or advanced treatment, so which is actually carried out to make the wastewater recyclable in various activities. So this is a typical sewage treatment scheme. So raw wastewater, it is going to the screening or comminutor, so where the waste or the larger particles are actually removed from the wastewater, and comminutor is actually used to break down the larger particles also, so where so to protect the downstream pumps and all. So second is the grit channel, as I told that it is used for the removal of inorganic impurities, and it is based on the specific gravity and of organic as well as inorganic pollutants. So basically inorganic pollutants, they may have a specific gravity of somewhere 2.5 to 2.65, whereas the organics, they have a specific gravity of around 1.5 something. So based on their specific gravity, we actually design the grit channel in such a way that only the inorganic impurities are removed. However, in practically, actually we can also expect some larger organic impurities may also be removed, but mainly it comprised of inorganic sludge. This is the second one, is the primary clarifier. So in the primary clarifier, here this overflow, which is the wastewater free from the or having reduced amount of suspended solids, it is sent to the next processing stage, which is secondary stage, and the underflow, which is settled down, it is actually the sludge, which is mainly organic in nature, which has to be disposed of. Then this is the secondary treatment. You can see the boundary there. So this boundary actually, so this is the one of the most commonly used biological process, which is called activated sludge system, which is used, which is comprised of two units. One is aerator. So where aeration is done, the waste primary effluent, so the wastewater or overflow from the primary clarifier is also termed as primary effluent, which is going to the aeration system where it is aerated, and then here from here this goes to the secondary clarifier or secondary sedimentation tank. So that's why it is first one it is called primary clarifier, it is called secondary clarifier. Here the nature of the sludge is different. This sludge is more compact, it is coming from the suspended impurities. Here it is actually the biological solids, mainly it is biological solids which are actually have some microbes and all also would be there, and then it is settled down. So in the activated sludge process, it's one of the main features is actually a portion of the sludge is returned to the aeration tank. There are many variations, so we will actually just talk about the basic fundamental about this process. So there is the actually two units are there, one is aerator and the another one is secondary clarifier. From the secondary clarifier, the sludge, the underflow, it has to be actually disposed of, but a portion of this sludge it is returned to the aeration tank. Why it is, that's why it is called activated sludge system, because this return sludge has active microorganisms which can start acting on the organics which are coming in the primary effluent, and then this treated wastewater it is sent to the it is sent for further processing or tertiary treatment. Now this is the second variation, so which is actually these are the two conventional methods which I am discussing here. The second one is the trickling filter system, this biological process. In trickling filter system, there is the first is there is a trickling filter would be there. So the water is normally sprinkled from the top, and it is not a filter kind of thing, because here we use large size stones which has large pore size. So basically this is also called fixed film system, fixed film. So where on the surface of the media which may be stones, or nowadays actually in the modern systems this is plastic, this is also used as the media and all. So there the microbial film is developed, and in that microbial film this organics are oxidized, so they get absorbed there and then these are oxidized. So this is the trickling filter, and then it is followed by a secondary sedimentation tank. So generally in most of the conventional biological systems there would be one unit where the oxidation and all will happen, and the second one would be the clarifier. And here in this system what happens that whatever the sludge is generated it has to be disposed of. No sludge recycling is done in this particular system, in trickling filter system. But here we can actually recycle effluent, already treated effluent we can recycle if required. Why it is required? Because sometimes it may happen if there is a low flow conditions, then this fixed film that may dried up, and then microbes may not get sufficient food for their survival as well as moisture. So if this effluent, a portion of effluent is recycled, then it remains wet, as well as some residual organics will still be present, and there may be some nitrogenous compounds which may also be present, and these can also be further removed there. So this is actually the trickling filter system, and from there it goes to the treated wastewater, it is sent for the secondary tertiary treatment there. Now schematic of sewage, so already I have discussed about this. So there is a RAS sludge, it is screens are there, then communitor is there, and there is a grid chamber, so grid disposal, and this is primary clarifier is there and all, and then this wastewater is going to the aeration tank, from aeration tank to the secondary clarifier, and then this activated sludge, there is some portion is actually recycled and the rest is going for the further treatment and disposal. And this is disinfection is also only given sometimes the final treatment, but nowadays as I mentioned that since it is required to recycle the treated sewage we have to give some tertiary treatment before going for recycling and all. Now here I am more specifically talking about the biological treatment processes. So the major aim of the secondary treatment is to remove at least 85% of biochemical oxygen demand and total solids from the RAS sewage. So typically if we go back to this process in the primary clarifier, we can have significant amount of suspended solids removal. It may be like 50-70% removal of the suspended solids, and in this process BOD removal also happens. That may be around 30-35% of BOD removal may also happen there. So here this is the purpose would be at least 85% of BOD and total solids removal from the RAS sewage. And in biological systems, microorganisms are used to remove organic pollutants, and these organisms basically they are consuming organic compounds as food and convert them into harmless compounds. In this process what happens that the sludge is also produced. Okay, so the sludge is produced, so the amount of sludge that is produced, some of the sludge is recycled back in the activated sludge process, but the rest has to be disposed of safely. So these are the two common biological methods which I have already discussed in the previous slides. So there is the trickling filter is there, and there is the activated sludge process. Trickling filter is an example of fixed or attached growth process, while activated sludge process is the suspended growth process. In addition to these processes, nowadays actually we have RBC systems, which is called rotary biological contactor system. Okay, so this is actually they have basically again there are the discs are there on which fixed film is developed, and they are actually these are rotating biological discs. So sometimes they are coming in contact with the atmosphere, where the from the atmosphere the air is actually used for the aerobic process, aerobic microbial degradation. Another system is sequencing batch reactor SBR, which is popularly called SBR. So in RBC also we require secondary clarifier, but in SBR system we don't require any secondary clarifier. All the processes happen this in one system only. So the sludge wastage also happens. So there is a cycle which is used, actually cycle time is used for various activities. So these activities include this fill and then react and then actually settle, and then this is the decanting. Okay, and then there would be some idle time would be there. So I am not discussing about those processes. In addition to these two more processes, we have MBBR. So this is moving bed bioreactors, as well as there is MBR, where this is membrane bioreactors. So several processes have been developed in recent times, and which can be also used in the sewage treatment plants. But these two, trickling filter and activated sludge process, these are most commonly and very old these treatment systems, which are still you will find in several this STPs. Trickling filter is a fixed growth system. So we have to remember this thing. So one is like, what is the difference between trickling filter and activated sludge process? So trickling filter is a fixed growth aerobic system. Water is sprinkled over the surface by means of spray nozzles or rotary distributors, and percolating sewage is collected at the bottom of the tank through under drainage system, and then the collected wastewater is conveyed to the secondary clarifier. The trickling filter, these are circular, and their cross section may be circular, and their diameter may be up to 60 meters. So it's quite large, but it can widely vary. And wastewater recirculation is done to maintain flow rate during periods of low flow to improve pollutant removal efficiency. This is the trickling filter unit. So this is a rotary distributor arm, and then the water is sprinkled over this. So this is a media, as I told, that either it may be stones. So conventionally these are stones, but we can have plastic media also. air may be passed from the bottom, and then the water, it is sprinkled, it is actually coming in contact with the fixed film on the surface of the media, and then water is coming down, and then the treated water, it is sent to the clarifier, and then some amount of water may be recycled into this. So this is the way this process works. And there are some parameters like recirculation. So recirculation ratio is expressed as QR by Q. So QR is the recirculated flow rate and Q is the RAS sewage flow rate, and R can be 0 to 3 depending upon the situation. There is hydraulic load, it is the another one, the rate at which the wastewater flow is applied to the filter surface, it is called hydraulic load, and it is expressed as Q plus QR over AS. So please note, this hydraulic load includes this recirculated flow rate also. So this is the total flow rate Q plus QR that is taken here. AS is the trickling filter surface area. So that is it is circular in nature. So it is given as pi by 4 d square. D is the diameter of the trickling filter. A typical value of high rate trickling filter is given as 20 meter cube per meter square per day. Organic load, it is the rate, it is refers to the rate at which organic material is applied to the trickling filter, and it is called as BOD load also. It is, its units are in kg per meter cube per day. For high rate trickling filters, its value may be 0.5 kg per meter cube per day. It is expressed as Q into BOD 5 and all, divided by the volume of trickling filter bed. Here please note, this does not include the QR. So that is the recirculated flow. It is only calculated based on the RAS sewage flow rate. Now this is the problem here. So there is one problem. Trickling filter has a diameter of 18 meter and a depth of 2 meter. It is operated with a direct recirculation. So here R is given as 1.5, D small d, that is diameter of the trickling filter, is 18 meter and depth is H is 2 meter, and the influent flow rate is 2.5 million liters per day. MLD stands for million liters per day. Influent BOD to the primary tank is 210 mg per liter. So it is to the primary clarifier, primary sedimentation tank, it is 210 mg per liter, and it is given that in the primary sedimentation tank around 30% of BOD is removed. So we can find out how much BOD is going into the secondary tank. Compute both the hydraulic load and the organic load on the trickling filter. So using the formula that we can do this. So this is like compute, so first we will compute surface area of the tank. So this is pi by 4 d square. So d is given here 18 meter. So we can calculate, this is 254.5 meter square. Volume is area into depth. So simply that we can calculate. Now recirculated flow rate, this is, we can use the formula that is given here, R equal to QR over Q. Using this we can find out QR, which is R multiplied by Q. Q is the untreated sewage flow rate, and that is 3.75 million liters per day. Total flow will be Q plus QR. So that is 2.5 plus 3.75. So this is 6.25, or we can write it in the form meter cube per day. So that is 6250 meter cube per day. Hydraulic load will include the recirculated flow also. So there is, therefore its formula Q plus QR over AS, so that we can find out. Organic load does not include QR, and this is Q into BOD by V. Now BOD in the trickling filter unit, which is entering into this, that we have to calculate. So this comes out to be 147 mg per liter. That is actually because this is 210, initial value was 210 and it is reduced by 30%. So 70% of 210, that is going to the trickling filter unit. Therefore BOD is taken as 147 here, and this value comes out to be 0.72 kg per meter cube per day. Now this is the activated sludge process. So activated sludge treatment, it is a suspended growth system. So where the wastewater in the aeration tank, the wastewater remains in suspension as well as microbial population or sludge remains in suspension. It is not attached to any media here. In this process, sewage effluent from primary sedimentation tank is mixed with activated and aerated for 4 to 8 hours. Typically it is 6 hours in the conventional process. But in some kind of systems which is called extended aeration system, we are not discussing this here, there it can be up to 24 hours also, but that is something in conventional system we will have from 4 to 8 hours. This is actually mixed liquor suspended solids. So that is the combination of activated sludge and wastewater, that is in aeration tank it is called mixed liquor, and the suspended solids are present. So solids present in the activated sludge as well as in the wastewater, so that we can calculate, and this is called mixed liquor suspended solids. Large concentration of aerobic microbes form an active suspension of biological solids, that's why it is called activated sludge. In aeration tank, microorganisms actually they oxidize the aeration tank. So this is the image. So simply this is raw, it is actually the treated primary effluent that is entering into the aeration tank, and then it is there is a secondary clarifier where it is settled down, and then the remaining waste. Now this is actually a problem on this. So this is like here this food to microorganism ratio is one of the important parameters. So we should have sufficient food available for the microbes to work on. So it varies, actually it should be around 0.2 to 0.5, and F by M ratio has some ratio, some unit. It is not unitless as the name suggests, F by M ratio, so that you will also see in this numerical. So the flow rate is 3 mld million liters per day, and the primary effluent has a BOD. So already it is given primary effluent which is coming from the primary clarifier has a 5-day BOD of 120 mg per liter. This mixed liquor suspended solids is to be kept at 2000 mg per liter. So that is, there is also some standards for that. It should be around 2000 mg per liter to 3500 mg per liter or so, and F by M ratio is 0.3. So F stands for food, M stands for microorganism, and if the SWD, this is side water depth, is 5 meter and the tank is to be 20 meter long, what should be its width? So this is one issue problem. So their volume is taken as, so first thing, how would you define F by M? So F is the food, food is Q multiplied by BOD 5. So whatever BOD that is actually coming, that is organics, this is food, and this is Q is the flow rate. So this is total food, Q into BOD 5, and M is the microorganisms. So this is V, volume into MLSS. MLSS is mg per liter and volume is liter. So there this is mg. So this is the total mass of the microorganisms. Okay, and this is Q, this is meter cube per day or whatever, MLD, million liters per day, and this is mg per liter. So basically we are calculating this mg per day. So the unit of F by M is day inverse. It is day inverse. So F by M ratio is to be 0.3 day inverse, right? So there it has some units. Now we can directly calculate the volume here. We have given all the values. So Q is 3 mld or 3000 meter cube per day. If we don't change the units of BOD and MLSS, both are in mg per liter, then these will be cancelled out. Therefore we did not change any units here. Is multiplied by 120 divided by 2000 into 0.3, and V equal to LBH. So we can consider this as a rectangular, and then we will find out the value of B. So that is the width of the tank. Now you might have noticed that all the processes in conventional conventional sewage treatment plant, they generate some kind of sludge. So basically we have to deal with this sludge, and this sludge management is one of the major issues with the STPs. So these are some values which are taken from one textbook actually. So primary, secondary and advanced or tertiary, that you can say. So this is the volume generated 2500 to 3500. This is percentage solids is only 3 to 7%. So, and this is for secondary, it is further less, 0.5 to 2. So basically this is not a kind of a solid. It can be considered is a high strength wastewater kind of thing. So in seawater we have approximately somewhere 3.5% of solids, and still it is kind of water. So same thing is like you can consider about this also. So it's 0.5 to 2% of solids there, and this is the dry solids quantity. So goals for processing solids is, one thing is volume reduction, the second thing is we can remove pathogens, pollutants and odors, third one is energy recovery or after its generation, and the last one may be production of beneficial use products. For example, we can again produce some compost kind of material. Now this is the generalized sludge processing flow diagram. In this there can be a combination of processes again to treat the sludge. So first is, this may be thickening. Thickening is and dewatering, both are used for the reduction of water content from the sludge. So thickening is actually that is used as first place. So we can reduce the moisture content present in the sludge to an extent, and then actually there we can go it for the dewatering also, further removal of water content from there. So we can use here like gravity thickeners are there, and this is centrifugation and all that can be used, which are energy intensive processes. So therefore it is good that we first go with the gravity thickening where the energy consumptions are low. After thickening also directly it can go to anaerobic digestion, and after anaerobic digestion the digestate which comes out, that can be subjected to dewatering and all. And here after thickening, incineration is generally not advisable, but theoretically it is also one of the options. And after dewatering actually we can make the waste the sludge liftable. Normally it is considered that after dewatering the sludge becomes liftable. So liftable is like when the sludge moisture content is actually that increased, that reduced to somewhere around 70 to 80% or so. And then it can be ash has to be landfilled, or we can go for land application, composting, co-composting, we can mix it with municipal solid waste and all, and then it can be achieved. So there is a combination of processes which can be used for sludge processing. Two major purposes is volume reduction and stabilization of organics. Now I am emphasizing on the anaerobic digesters because this is one of the processes. Anaerobic treatment is given to the sludge. So here this is single stage standard rate anaerobic digester. So this is only one digester is there, and the sludge is entered into this, and then several layers are formed. So it stays there for long period for several days, and then we can have this scum. This is oil scum may be there on the top, then this is supernatant. Here we provide heater also, so that because it is done at a particular temperature, so it is in the mesophilic or thermophilic range. If we are doing in the mesophilic range, then the temperature should be around 35 degrees centigrade or so, and then the digested sludge is removed from there. In the second one it is two stage aerobic digester. So in the first one it is heater is there, and this is the mixing zone. So all the contents are mixed properly, and this there is a gas outlet, and then the after mixing for short duration it is sent to the next tank, other tank here. This is at the second stage where we allow the various layers to form, and then here the amount of gas is much less, and then the sludge is removed from there. Now digested sludge, it is stable organic matter free from pathogens, reduced volume approximately 1/3 of the original. The supernatant liquor may have high BOD, so we can say that is still 3000 milligram per liter, and the major product is actually biogas which is coming from this. So this contains mainly methane, which is 65 to 70%, 25 to 30% is CO2 is produced, and some trace gases are also may produce. So this is the typical gas production, that is 0.75 to 1.12 meter cube per kg of the volatile solids destroyed. and its heating value is approximately, that is 22.4 megajoule per meter cube. Be used as the digester gas, or biogas can be used as fuel for boiler and IC engines and internal combustion engines and in cogeneration. So we can use it as for the land application as energy source if the digestate or the product is, or compost, even compost is also produced here. So if it is of low quality, then it can be used as a landfill cover material. Now I am talking in brief about the tertiary treatment process. So there is, like, we can have chemical precipitation for phosphorus removal, nitrification and denitrification process is basically for the removal of nitrogen, because if the wastewater has to be disposed in the still water body like lake or pond, then it may cause eutrophication. If there are sufficient nutrients are present, we can go for filtration for the removal of residual BOD and TSS, and land treatment is also done. So in the next slide I will be talking about the land treatment method. So there are three types of land treatment methods. So one is slow rate, which is actually the objective is for the irrigation. So there we can go for crop growth and all. So that is one purpose. The second one is the rapid infiltration, where actually in the rapid infiltration the purpose is to groundwater recharge, and it can effectively remove this BOD, TSS and phosphorus, because phosphorus has good actually attachment with the soil particles and all. Slow rate actually it gives very good results in terms of like removal of residual pollutants. Overflow rate, it is the third one, where the water is allowed to flow over land at a mild slope, and then there in this process BOD and nitrogen is removed. So this is the images of various types of systems. So here this is water is applied and then it goes to it is used for the plant growth. Here this is in rapid infiltration, it has to be impervious zone, so that water is percolating there also, and it should be free from suspended impurities and all. This is the overland flow rate, where the slope is taken to 2% approximately, and the water is actually passed through this and then it is collected in the ditch. So this is something that. Now favorable conditions for the effluent irrigation. So this is natural water body should not be located in the close vicinity. Irrigation water is not easily available, and the method of disposal is useful where the area is has low rainfall and soil is porous and sandy, and water table should not be located at shallow depths. But if you are continuously applying the sewage, actually this is one of the practices which has been used in the past. Sewage is used actually on the land directly for the for disposal. So continuous application of sewage on land causes the clogging of soil pores because of the suspended impurities and all, and then it prevents the free air circulation, which causes the anaerobic conditions, and as a result of this, reduced gases like methane, H2S and all, this will be liberated, and then it causes actually the soil clogging. It is termed as sewage sickness. How can we prevent this? So we do primary treatment, at least primary treatment of sewage. First thing, the land should be actually having impervious soil, so that this some water is percolated and all. Proper under drainage system has to be provided, giving rest to the land. So after applying sewage, we should not actually repeatedly applying sewage on the land, and then it should be rotation of crops and applying at shallow depths. And now if the land is already sewage sick, then we can improve by plowing and exposing it to the atmosphere for some period. So one of the methods which is actually very old method and widely used, this is on-site wastewater disposal. So the wastewater or sewage which is produced from our home, that is treated in septic tanks. So in lightly populated suburban or rural areas, a system of disposal of wastewater from individual houses or a small community can be provided in the ground. This is called on-site subsurface wastewater disposal. So here, this is what are the important factors: soil texture, permeability and depth of groundwater and bedrock. We should know that, we should understand that what is the permeability of soil and what is the depth of the water table, so that the sewage is not contaminating our this groundwater. So here, to understand this permeability and all, there is a percolation test is conducted. Now septic tank, what is septic tank? It is an on-site sewage disposal method. It is like a sedimentation tank with longer detention period. These are buried and watertight pits, remove sweatable matter, partially digest the organics by anaerobic process. So basically here anaerobic biological process takes place, and some portion of organic matter is converted into methane and this CO2 and H2S. A scum of this oily fraction, it rises to the top, and partially clarified liquid is allowed to flow through an mixture. So this is a schematic of one system where there are two partitions are there. So this is input buffel is provided so that the water is going in the downward direction and the lighter material rises up to this up to the surface. Sludge is actually suspended impurities settle down, and then from there it is the another, it goes into the second chamber. In the second chamber the scum is also less and also the suspended impurities are also less, and this is the treated wastewater is actually allowed to go out to the soak pit or to the leaching field. Now how would you dispose the effluent that is coming out from the septic tank? So in the leaching field we can do. So this is absorption, or leaching field distributes the liquid uniformly over a sizable area. As it flows through the soil voids, microbes and pollutants are removed from the effluent. So it will have actually typical leaching field, it will contain there would be separate trenches would be there, which will have some perforated pipes and all, which actually helps in spreading of the wastewater. And the design of an absorption field requires determination of required number and length of laterals or trenches. So this is the drain field or leaching field here. So it is coming septic tank, it is coming water is coming, there is a septic tank, there would be a distribution box, and then the water is distributed in different laterals or trenches, and then it is going down. During the process, when it goes down deep, it is actually cleaned, the water is cleaned by the natural processes of microbes and all, or filtration. Second way is there may be soak pit or seepage pit. When the site is too small, we can't actually construct this laterals and trenches. For that, then we can have a deeper excavation which takes lesser area and are used for subsurface disposal. But we have to ensure that water table is at least 1.2 meter below the bottom of the pit to protect the water quality, and this is typically they are 3 meter in diameter and around 4.5 meter deep and all. Perk rate, actually that is percolation rate, which should be calculated, which should be determined, it is 30 minutes per inch. So its units are in minutes per inch, not in inch per minute and all, right. So that should be noticed here. This is typical, this soak pit is there, so it has to be properly lined also, so that it is water is not going out from the sides. So that care we should take here. Now solid quantity which is actually produced from the septic tank, it refers to the partially treated sludge stored in this septic tank. This is called septage, and its BOD is 6000 mg per liter, TSS is 15,000 mg per liter. So it contains significant amount of pollutants and it has to be treated. It should be actually transferred to the sewage treatment plant and should be treated in proper manner. Other disposal methods may be like we are co-disposing this with solid waste and then applying to the land. So what are the advantages of septic tank? First thing, it is easy for to construct and it doesn't require skilled supervision. No sewerage system, no network of pipes is required for this. and it can reduce significant BOD and suspended solids if these are maintained properly. Sludge volume which has to be dealt with is much less compared to the normal sedimentation tank, because here this is anaerobic treatment is also happening, so some sludge is digested also, and it is best suited for rural areas and for isolated buildings. What are the disadvantages? If it is not working properly, then the quality of the effluent may be poor, and then it can also contaminate the adjacent environment. Size requirements sometimes may be high depending upon the number of people living in that locality. Leakage of gas may cause bad smells and environmental pollution. So this is because methane is generated, so it has to be vented in a safe manner. Otherwise, and pressure should not be allowed to form in the within the tank also, because methane actually it is a explosive gas also. If it is present in the atmosphere between 5 to 15%, then actually in air, then it can explode also. Periodic cleaning, it is a difficult task here. So in this session I have discussed about conventional sewage treatment plant as well as septic tank, which is a conventional method also. These are the in the detached houses, and land treatment methods. So thank you very much.